Hi there, welcome back to this channel. In today's video, we are going to be talking about the Cartesian geometry. Now you see the Cartesian geometry, first it was named after a renowned mathematician at that time of the 15th century, Descartes. So Cartesian geometry. Now it is just the aspect of precalculus where we use our knowledge of functions to analyze a line. So it is fundamental to note that when we started function, we talked about types of function, a linear function as a type of function. So all we'll be dealing with here is just lines. Is that okay? A linear function basically. Now, so it is also discovered that it is not just discovered. I mean, as it's a fact that for every x value there is a y value. So if I have a straight line which is a product of a function, a particular function, each point on that line represents two coordinates. So first we have to even define what a line is. A line is basically points the distance between two or more points. That's a line. The distance between two or more points. So if I have a point, so if I say the distance between 2 points, for example, so if I pick a point here, there is something in physics, there's something called frame of reference. So there should be an angle from which we are viewing this point. Do you understand? So in order to understand this, we come up with what is called coordinate geometry. We come up with what's called coordinates. Is that okay? So coordinate geometry simply means we are discussing coordinates. Coordinates are basically numbers that represent points on a line. Is that okay? Coordinates are numbers that represent what? Points on a line. So what mathematicians came up with was to have two planes on which our line can be defined or measured. So for example, they came up with this, with an x-plane, which is a number line consisting of various possible infinite number of points that we can have on this horizontal axis. So it's called the horizontal axis, and they called it the x-plane or x-axis, and another y-plane or y-axis around which we can have infinite possible number of points on the vertical plane. Is that okay? Now, one thing they also did was that it was noticed that the point here is called origin, and that this point is called origin, and any point, so if I pick any point here, for example, is going to correspond to a particular x value and a particular y value. It's going to correspond to a particular x value and correspond to a particular y value here. So if I pick a point here also, it corresponds to a particular x value, corresponds to a particular y value. If I pick a point here, particular x value here, particular y value. Is that okay? Now, one other thing they noticed was that this kind of geometry actually splits, divide the plane into four parts. It divides the plane into what? 4 parts. So we call those parts quadrants. We call those parts what? Quadrants. So this being the first quadrant, second quadrant, third, and fourth quadrant. So as I was saying, I said if I picked a point, so if I picked this point has a particular x value, because we said it corresponds to a particular what? X here, and a particular y value corresponds to a particular y here. So for example, if I have my line, for example, I have my line like this. If I have a line like this, for example, and I picked this point has an x value, and this same point corresponds to a particular y value. Is that okay? So that is all that we want to talk about how these lines and the points are defined and measured. That is all we want to talk about here. So one thing is now this: the points, the x value that this point has is called the abscissa. It's called the abscissa. Hope I spelled it well. While the y value that it has is called the ordinate. So any point, for every point we have a particular x value and a particular y value. So its x value will be called it's abscissa and it's written first. Is that okay? So we always write x, comma, y. So this is what we call a coordinate for a particular point. Coordinates for a particular point. Good. So, and this y value we said is called the ordinate, and so we say we write abscissa first before the ordinate. So in this point, in this topic, we're going to be dealing with the following. The first one is how to find distance between 2 points. And listen, don't you say that you already mastered this, you already know this. If you are still knowing it by cramming the formula, such that in the exam you now ask your friends, hey, James, what's the answer to that question? What's the formula for that distance again? You have to learn the way it is coined. The formula is derived. Do you understand? And that's the essence of this channel. Make sure to understand and not just cram for exams. You understand? All right. So we're going to be dealing with distance between 2 points. So we'll be deriving the equation and be using it to solve a question at least. Then the next is we are going to be determining the midpoint of a line, the middle of a line. Then we are also going to be talking about collinear points. Then we'll talk about gradient, what is called gradient or slope. What is called the gradient or the slope. Then lastly, we're talking about equations of lines. So there are equations that, so if I give you a line, for example, and I give you certain values, certain properties, you can compute the equation for me. So that is what we are going to be dealing with there, equation of the line. Then lastly, we are going to be solving questions on this. We're also going to be dealing with angle between 2 points, angle between 2 lines. So it is in angle between two lines I will be talking about perpendicularity and parallelism. Parallelism and perpendicularity. Remember, pause it. So let's talk about distance between 2 points, for example, or the length of a line. That's just what we're dealing with here. The distance between 2 points or the length of a line. Now, how do we determine the length of a line? So if I have my coordinate system here, my Cartesian planes here, and I have this line. So say we name this line X and Y. Okay, no, I don't want us to use X, Y. Let's use AB. All right. So because this is our X and Y and X planes. So these are negative axes. Is that okay? We have on the opposite sides of each plane, we have negative axis. Is that okay? All right. So, but if we're to determine the length of this line, how would we do that? Now, the first thing to note, go and get the gate. Do you remember? Get the gate. So the first thing to note is the fact that this point corresponds to a particular x1 value and a particular y1 value. Particular x1 value here and a particular y1 value. So these are the coordinates for this point. This point B also, so let's put our point on top. Okay, let's put our point. We'll put A here. So let's put our coordinates on top. So this point corresponds to a particular x1 and y1 value. While this point also corresponds to a particular second x value, we call it x2, and a second y value, we call it y2. So we have x2, y2. Now just stick with me, you're going to understand this. Now, how do we now analyze the distance between these 2 points from here to here? So if you look at this vividly, it looks like a right-angled triangle, isn't it? So if it's a right-angled triangle, it therefore means it should follow Pythagoras' theorem. Pythagoras' theorem. And what does the Pythagoras theorem say? It says the hypotenuse square is equal to what? Opposite squared plus adjacent squared. And what is adjacent here? What is the hypotenuse here? Is this longest part that we're determining. So if we are to find the length of this side, It means we are just looking for the hypotenuse. So it therefore means that this point here is what? Which is our hypotenuse, considering that this is our angle here, angle theta, this will be our opposite. If this were to be our angle theta, this will be our opposite. So regardless of where is the opposite or the adjacent, it's not so important now. The major thing is that since it is a right angle, it must be in conformity with the Pythagoras theorem, and also this side is going to be the hypotenuse, being the longest side. Okay. Now, how do we do that? You know that this place is our opposite. We said this is our hypotenuse. This will be our, this will be our adjacent with respect to this angle. This will be our opposite. So our adjacent here, first our hypotenuse is what we're looking for, which will be our line AB. Then so our hypotenuse is going to be our line AB. So we said that one squared is equal to this O is this place, right? And what is O? O is the distance from here to this place, isn't it? And what is the distance from here to here? It's y2 and y1, right? When we subtract y1 from y2, that's the distance from here to here. Then plus the adjacent is going to be the distance from here to here, which is just our x2 minus x1. So now this squared and this squared. All right. So what do we have as the formula for our AB? Our AB therefore becomes the square root of y2 minus y1 all squared plus x2 minus x1 all squared. So you don't have to cram anything. You don't have to cram this from. Just remember that it was gotten from what? Our Pythagoras theorem. The hypotenuse is what we're looking for, which is the length of the line. Therefore, we have this guy minus y2 minus y1 all squared plus x2 minus x1 all squared, and the square root of all of that. And that is the formula for finding that. So if you have to find distance between 2 points, A with the coordinates minus 2 and 3, and B with the coordinates minus 1 and 4. How do you find the distance? So you basically use our formula. AB will be equal to what? The square root of. So the first thing to do is to label. So this will be our x1 and this will be our y1. Remember I told you it's always x before y. X before y. So this will be our x2 and y2. Is that okay? So y2 minus y1, that will be 4 minus 3 all squared plus, remember that, x2, which is minus 1, minus x1, which is minus 2, all squared. So we have AB will be equal to the square root of 4 minus 3 is 1. 1 squared is 1 plus minus 1 plus, minus 1 plus 2, because this will be minus and minus plus. So minus 1 plus 2 is what? It's still 1. So what do we have? 1 squared is also 1. So our answer is root 2. And that is the length of our line AB. Now, it depends on what unit you are giving. Since you are not giving any units, you just write root 2 units. Is that okay? So, and that is it for the distance between 2 points. You should, or the length of a line, you should know how it is gotten. So, you don't need to cram the formula, understand the way the formula is gotten. So, any day you are stuck, you can easily reassess the formula again and then use it. All right, let's go to the second one, which is the midpoint of a line. So taking the coordinate system again, if I had a line like this, for example, our line, let's use AB, for example. Now, if I were told to determine the point, the midpoint of this line, now this would be will probably be the midpoint. It will be around here. So we know that there is a point here which is our x1, comma y1, our x1 and y1, and there's another point here which is our x2, y2. All right. So this point also is going to be, we can name it a point M. This point M is going to have its own coordinate x and y. It's going to have a particular x value and a particular y value. All right. So that's going to be the midpoint of the line. So how do we now determine the values or the coordinates of this point? It's very simple. Now, if I made this into a right angle and made this into another right angle, I could call this point O and call this point P, for example. Now, you would agree with me that because AN is equal since AM is equal to MB, the distance AM, provided that this point is the midpoint, the distance AM should be equal to MB. Is that okay? Since that is the case, you will also agree with me, therefore, that the distance AP should be equal to what? MO. This distance AP should be equal to what? MO. And this P, this AP, so let me write this. I said since AM is equal to MB, AP should also be equal to OM, right? Okay. So since we've agreed on this point here will be our x1 here. This point here will be our x coordinate. Here it will be our y. Here will be our y2. Here will be our y1. So this place will be our x2. Now, since AP and OM is the same, okay, then we can say that AAP, which is the distance between here and here, the distance between here and here will be x minus x1, right? So we said it must be equal to OM, which is from here to here, so which is x2 minus x, because it is the greater minus the smaller. So x is greater than x1 here, so it's x minus x1, and this side is what? X2 minus x1. So minus x. So how do we determine x? Therefore, we can bring x to this side so that we have x minus, we turn to plus, so x plus x will be equal to x2 plus x1. Do you understand? Yes. So we have x plus x is what? 2x is equal to x squared plus, x2, the x2 we are looking for, right? And x1, right? Plus x1. So to get x, what do we do? Divide both sides by 2. So x will be equal to x2 plus x1 over 2. So this will be the formula for looking for what? For finding the formula to find the midpoint of our line. So that's the first coordinate. And since this works for the x, definitely must work for the y, which will mean that MP, the distance from here to here, provided that they have this line, this is the midpoint. Since they have the same slope from here to here, which will be MP, must be equal to from here to here, which will be BO. Is that okay? So from here to here will be y1, y minus y1, and from here to here must be what? y2 minus y. So if you work the same math, y also will be y2 minus y1 over 2. If you work the math. So our coordinates for the midpoint will be what? Our midpoint coordinate is equal to, check, is it capturing this frame? Will be x2 minus x1 over 2, comma, y2 minus y1 over 2. And this is the formula for obtaining the midpoint of a, don't shift it, don't, because of that point. I'm still going back there. So this is the formula for obtaining the midpoint of the line. Now let's talk about collinear points. Now, that is very simple. In fact, we are not going to be dealing with any formulas with that. We just want to define what collinear points are. The word co means together. So anytime you hear the word co, for example, give me a word that starts with co. Coefficient. Okay, give me another one. You see the word coefficient means coefficient. Efficient means what? Producing results, right? So it means that they are producing results together. That's when coefficients together. Give me another word, co something. Cooperate. Cooperate means two or more people work together. They operate together. Another one. Don't worry. So collinear means what? We have a line. If we have a line, there will be two. If you say two or more points are collinear, it means they are points on the same line with the same slope. So these 2 points are collinear. Why? Because they are the same point. They are points on the same line. They are points on the same line. But if your line was not consistent, let's say your line was a curve, these 2 points are not collinear. Why? Because at different points, at this point, the slope at this point is different from the slope at this point. And that is our ultimate goal to resolve things like this. But I'm just trying to emphasize what collinear points mean. Collinear point means that 2 points on a particular line, 2 or more points on a particular line. All right. So, are you seeing on it? Okay, you're not done. All right, let's talk about the gradients now. The gradient. Check how many minutes. Check how many minutes. Gradient or slope. How many minutes? So if I have a line like this, for example, if I have my line like this, and you are told to find the gradient. Now, the first thing is understand that gradient is represented by the letter M generally. Is that okay? So, and I don't know why. Is that okay? I don't know why, but but it looks like it's supposed to be G or S. I mean, but the first thing you must know about gradient. Gradient simply means the slope of something. That is how slopey something is. Okay, for example, think of it this way. Look at this point on my board. Look at this point on my board. If with respect to this point, if I draw a line like this, look at the line like this, look at another line like this, look at another line like this, and look at another line like this, and look at another line like this. If I put a ball here, for example, and I put a ball here, and I put a ball here, and here, and here, on where will you experience the fastest a spontaneous the fastest spontaneous reaction of rolling of the ball? It is on this first one that the ball will find it easiest to roll down. Although at the end of the day, they might proceed with almost the same acceleration, but this guys, for example, if you put the ball here, it will take it time to achieve its greatest speed. This one too, to take it time to attain its greatest speed. This one also to take it time to attain its greatest. It will not take some time, relatively less time, and this one no time at all. Is that okay? So based off of this, what I mean to ask is, which one is the steepest? So the reason why they will attain their highest speeds differently at different times is because of the steepness of those lines. So because this one is more steepy than all of these ones, it's going to attain the speed faster. So steepness is with respect to how much high you are relative of how low you are. I don't know if you got that. How high you are relative to how low you are. So because of that, we call gradient, we call it rise over run. So the relationship between your rise and your run, like you're standing and you're lying down. So in what position? So this one is sleeping more than it's running. So this guy is running more than it is rising. So if you want to have a higher slope, what does it mean? It means you have to rise more than you run. So look at this guy, it is rising. So that's why you see that even if I were to draw the same line, the same length of line or distance of line for each guy, this one will cover a larger run than this guy, because if I were to erect something like this at the same angle here, it's going to get to somewhere around there. Why? Because this guy is rising more than it is what? Running. And remember, I said the rise has to be higher so that this thing must be great. The gradient must be great. Why? Because if you divide a big number with a smaller number, you get a big number. Than when you divide when you use a big number to divide a small number. So to have a great slope, you must rise more than you run. Do you understand? So we call gradient the relationship between our rising and our running. And how much do we rise? How do we know how much we rise? One thing with linear graphs, with straight lines, is this. The slope is always the same anywhere you take them. And how do we take them? we said that it is rise over run. How do we know our rise? Our rise is always what? On our y-axis, and our run is on our x-axis. So it is always the change in our y over the change in x. So and what will be the change in our y? We need at least 2 points. So we have y2 minus y1 over x2 minus x1. So this is the formula for the gradient. So our particular, so if we pick any 2 points here, if you pick these 2 points, you're going to get the same gradient as when we pick these 2 points. As in, if I take the gradient here like this, so I have a particular x value here, particular y value here, y value here. It's the same as when we take the gradient here, particular x value here, particular x value here, particular y value here, particular y value here. Is that okay? So this is where we take it. It's also the same as when I take the gradient here. Do you understand? Of this line, the gradient will be the same throughout. That's what is peculiar to a linear graph. So we have our x2 here, we have our x1 here, we have our y1 here, we have our y2 here. So the gradients will just be the ratio of both differences. All right? So I said, remember the rule that says that the sum of two interior angles, sum of two interior angles is equal to opposite exterior angle. So the sum of this angle and this angle will be equal to this. So it means that theta 2 is equal to theta 1 plus alpha, isn't it? So it therefore means that alpha is equal to theta 2 minus theta 1. You agree, right? This one comes here, right? Theta 2 minus theta 1. So it therefore means that, so we are looking for the angle. We can therefore use tan alpha, right? Tan alpha is the gradient of this line, isn't it? Then, if tan alpha is a particular, whatever tan alpha is, must be what tan this is, because this and this is the same as alpha, right? This minus this is the same as alpha. So it's equal to tan theta 2 minus theta 1, isn't it? Tan theta 2 minus theta 1. All right. So what does this tell us? From tangent functions, subtraction of two angles, what do we have? We have that, remember that tan A minus B is equal to tan A minus tan B over 1. If you have minus here, the one below will be plus. So if it was tan A plus B, to be tan A plus tan B over 1 minus. All right. So here we have we have 1 tan A minus tan B over 1 plus tan A tan B. All right. So that is what we have there. And Jemima. So if that is the case, therefore, you have tan A will be this. So we have tan into bracket theta 2 minus theta 1. Therefore, we just copy this. This becomes what? Tan what? Theta 2 minus tan theta 1 all over 1 plus tan theta 2 tan theta 1. And remember that the gradient of this line itself, tan theta 1, is equal to gradient 1. So it has is m1, right? Gradient 1. And the gradient of this second line, tan theta 2, is equal to m2. I mean, of course, we said if we took the gradient like this, it would be the opposite of our adjacent. That thing we did here, all right? So here, we are only naming them 1 and 2. So it means we can now substitute them into this equation so that the angle between those two lines will be equal to, let's bring it here, tan theta 2 is what? m2. m2 minus m1, which is tan theta 1, over 1 plus m2, m1. And this will be the equation for the angle between them, angle between two lines. So just before we talk about parallelism and perpendicularity, I mean, from here we should now understand parallelism and perpendicularity. So with this equation, we can find the angle between two lines. So we are given the equation of two lines, for example. We can basically use that equation, maneuver, then find the gradient, and use this to find the angle, the tan alpha, which is the angle between those two lines. All right. So now, what is the condition for parallelism? Parallelism means the condition in which two lines are parallel. So the condition for two lines to be parallel, so if I have my coordinate here, for this line to be parallel to this line, it means that they have gradients, the same gradients. So that theta 1, tan theta 2 is equal to tan theta 1. The gradient of this line was equal to the gradient. So M1 was equal to M2 in essence. Do you understand? So that is the condition for parallelism. And the condition for perpendicularity, for two lines perpendicular, it means that, so, and that is the case where the numerator here is equal to 0. For parallelism, the numerator is 0, so M2 minus M1 is equal to 0, so M2 is equal to M1. So that is the condition for parallelism. While the condition for perpendicularity is the case where the denominator is equal to 0, 1 plus M2 M1. So if this is equal to 0, therefore we have, that goes there, we have M2 M1 is equal to 1. So what do we have? M1 will be equal to 1. Now this is negative 1 because it's supposed to be minus 1. So minus 1 over M2, or M2 is equal to minus 1 over M1. So the condition for parallelism is when the numerator of this guy is equal to 0. So M1 will be equal to M2. And for perpendicularity, the denominator is 0. And we have this. All right. Jemima. I see you. Good night. So let's talk about the equation of a line. So what are the equations of lines? Now, equations of a line. Equations of a line. Now, the equations of a line depend on different conditions. So we usually determine the equation of a line based on the gradient of that line. So it is for us to be able to determine the equation of a line, we must be given either of these three things. Either we are given the gradient of that line and the intercept of that line. We call that the gradient and intercept method. So we have three methods. We have the gradient, and y-intercept. Is that okay? Y-intercept simply means where the line cuts the y-axis. So that's the first method, and let's see that. So if we have gradient M and intercept C, we are given, what does this mean? At this point C, we can see find 2 points, yes. At this point C, it means that we have a particular x value, a particular point y, and a particular point that has coordinates x, y, and another point that has coordinates 0 and c. Why? Because we said y-intercept is the point where it cuts y-axis. So the point where it cuts y-axis, at this point, the x value is 0, and the y value to have only a y value. So this is the point where we call the intercept. So this is our c. So at that point, x will be 0, and we have another x value and a particular y value. So since we have these 4 coordinates here, since we have these 4 coordinates here, we can therefore say that our gradient is always change in y over change in x, right? Our change in y simply means this y minus c, which is y2 minus y1, remember, over x2 minus x1, 0 minus x. Or in fact, this should be our first values. This should be let's use this as our first value. Let's use it as our first value. The reason why I said that is so that this one will not be negative. This one will not be negative. And it doesn't really change much. So it means that our first coordinate will be 0 and x, and our second coordinate will be x and y. Is that okay? I mean, the reason is also that our x value must be greater than 0. Is that okay? So what does this tell us? This tells us that y2 minus y1, 0 comma c, because y intersects x and y. I hope you can get what I'm saying. This point is 0, and it has a corresponding c, which is the y value, and another point x, any other point x and y. So our gradient to be changing y will be this minus this, which is our y2 minus y1 over this minus this, x minus 0. So that m therefore becomes y minus c over x. So when we cross multiply, we make y the sorry formula. We have y equal to mx. So that y therefore becomes mx plus c. And this is the equation of a line. Remember, the equation of a line is usually written with the y being the subject of the formula. So that is the way the equation of the line is. And if you look at it, the highest power of our unknown here is what is 1. So that's why it's called a linear graph. That's why it's called a linear function or a linear equation. So this is why it's the same as our f of x is equal to what? mx plus c. But since f of x is not used, just y is used, it's usually written with respect to y that way. So y equal to mx plus c. So this is the first method, the gradient and intercept method. So what if we were given another? So what if we were given another? What if we were given a point, gradient and 1 point? You know, here we're giving only intercept. What if we were giving gradient and we're giving 1 point? Gradient and 1 point method. How do we determine the equation of that linear function? So what we'll do is this. Since we are giving our gradient and a particular 1 point. So 1 point there will correspond to a particular x1 value and a particular y1 value, isn't it? So what does that tell you? It means that our second value should be a particular x and a particular y. We don't know. You understand? So it means that our gradient will therefore be equal to what? Still remember, y is always changing y, rise over run, right? So changing y is y. Y2 will be our y, because we don't know our y2, so we cannot use y2 here. So we are just using any particular y minus this y1 over any particular x minus this x1. Any particular x minus x1. So that we have m will be equal to y minus y1 over x minus x1. And therefore y minus y1 will be equal to m into bracket x minus x1. And then you can, open up the bracket and all of that. But this will correspond to the equation, the second equation. So this will be our equation 1, and this will be equation 2. So what if we are also asked we're now giving our giving 2 exact points. So that is where we now use 2 points, greater than 2 points. 2 points method. So if we're giving 2 points, we basically know that our gradient will be equal to what? In fact, if we are giving 2 points, we will not be giving gradient. We will find the gradient ourselves. So y2 minus c our rise over run. Because we are giving 2 points here. We are giving x1 and giving y1 and x2 and y2. Those are the 2 points. This is 1 point, this is the second point. Is that okay? So y2 minus y1 over x2 minus x1. And this will be the formula. You maneuver your equation and you find the formula for y. Is that okay? So let's solve some question. So what if we have a question like, we stopped solving question from the midpoint, so I'm going to start with a question that deals with the midpoint. So what if a question says, find the midpoint of a line with the coordinates, a line AB with the coordinates, AB with the coordinates 3, minus 2 and 2, 0. If you are told to find the midpoint here, this will be your x1, y1, x2, y2. So remember that the midpoint is given by x2 minus x1 over 2. Now this is why I said you shouldn't cram formulas. just remember what you did there. What we did was we compared 2 points on the line, which was that x minus x1 was equal to x2 minus x, isn't it? And we said that x minus x plus x is 2x is equal to x2 plus x1, right? So this is supposed to be plus. So you see, you can easily forget the formula if you don't know where the equation comes from. So you should know where it is coming from. So it means that our midpoints are equal to this, comma, and y2 plus y1 over 2. So what do we have here? What have we? We have x2, which is giving us 2 plus x1, 3 over 2, comma, y2, which is 0, plus minus 2 over 2. And here we're going to have what? 5 over 2, which is 2.5, or 2.5, anywhere you want to put it, comma, minus 2 over 2, that is minus 1. Minus 1. So this is our midpoint, our x value and our y value of the midpoint. Is that okay? Now, what if for this same, no, let's now use it to find the equation. Let's find the equation of line using gradient and intercept method. If you are given the intercept of 2, comma, and a gradient of 5, for example, so m is 5, or let's say m was 2, c is 5. How do we find the equation of a line? It's very simple. Remember we said that m from here will be equal to y minus c, right? Y minus c over x. So what is our m value? M value is 2 is equal to, either way you can just substitute into this equation, but I just want to solve from where we have it. Y minus 5, which is our c, over x. So what do we have? We have y minus 5 is equal to 2x. So that y will be equal to what? 2x minus, plus 5. And this will be the equation of the line. So what if we are given, what if we are told to find the, what if we are told to find the angle between these points and this line and another line, y equal to 3x minus 2. What if we are told to find the angle between these 2 points? Remember the formula. The tan of that angle is equal to what? m2 minus m1, m2 minus m1, yes, over 1 plus m1, m2. So all we have to do is find the gradient. We already know that the gradient. Now, when you have a formula like this, all you have to do is take the gradient. The gradient is always the guy, which is the coefficient of x. The gradient is always the coefficient of x. What is the coefficient of x here? 2. What is the coefficient of x here? 3. So our m1 is 2, m2 is 3, isn't it? So m2 is 3. We have 3 minus 2 over 1 plus m1, 2 times m2, 3. So we have 3 minus 1 minus 2 is 1 over 1 plus 2 times 3 is 6. So we have tan alpha to be equal to 1 over 1 plus 6, 7. Right. What does that give you? Alpha will be equal to the tan inverse of 0.1412, like that. So if you do this, the tan inverse, you're going to guess the tan inverse of this angle. I don't have a calculator with me now. So in fact, yeah. So while you are at it, give me the tan inverse of 0.142 and post it in the comments section below as a sign that you have understood all that we have done today. In the next video, I'm going to be solving questions on this Cartesian geometry. See you in that video. Do not miss out on it because I'm going to be solving many questions. So God bless you as you subscribe to this channel and share with your friends this content, and comment on the comment section any question you've tried on this before that you did not get, so that we can work together, and maybe able to solve it. Who knows, right? And see you in the next video. God bless you.